Good evening, everyone. Thank you so much for coming this weekday. And I'm Padma Ayala, CEO and founder of Virtue Teching, and I'm also founder of Seattle Data AI Security. This journey started. Somebody was asking me when did we start this journey? This was like in 2021, post COVID. People, I want everybody to come and learn about AI because even back then 2021, things were changing. So we thought there should be a $0 networking platform for people to learn, connect, share, and AI is by minute and second is, so many things are changing so fast. So to keep up with that, um, so with that commitment, we started, and somebody was telling me a minute ago. Originally we used to do it in Microsoft Reactor. Less than there were days that 3 or 4 people used to show up, and then from there to last event, if you guys anybody was here on the 4th of April, we did a security tour, 750 registrations, and it's long way that we have come, and we've been doing every month. Not an easy job, trust me, it's very time consuming, and um uh, so I think Chitra and Fani will be talking more. I didn't wanted to read the mission vision, but pretty much I already told that. So my ask, will you be covering about sponsors? That's yeah. So specifically, we are, it's after 2.5 years. I think we have earned your trust. We are really looking for sponsors. So for example, we are doing some roundtable VIP, you know, so somebody is interested of our new products or startups, their, product adoptions, or we have done hackathons. Our hackathon story is a very different story. We found sponsors. There are two young ladies who got jobs. I think I saw them somewhere. Meghna and Purnima. Yeah, yeah. So they can vouch for this. We went to universities, asked the students to participate. We brought the volunteers. The sponsors. So students got an opportunity to work on business problems, and this company saw the real talent for 8 weeks, and they have observed, and the winners in the end got internships and jobs. So this is another way. Yeah, we tried our bit in helping freshers to get jobs. So there are many ways we are trying, but we need support. So we're looking for sponsors again. So with that said, thank you again, and I wanted to invite Chitra here. She will walk you through what we have done and what are the upcoming events and stuff like that. And then Funny, I think, is also going to give you more details. Thanks.
Thank you, Padma. Welcome in, everybody. How are you guys doing? How's the energy?
Good.
Great. Yeah. Nice to hear all of your voices. I just want to quickly show you where you can see our upcoming events. And if you've missed, how many of you here from where were able to uh, come up to this place for the Global Security Tour? That's great. Yeah, I see very few hands, but you definitely haven't missed it out. This is our YouTube channel. We have all of the sessions gone up there. You can just find it in one of our playlists. It says the Global Security Tour. You'll be able to see each speaker's session right there, and all of the keynote, everything. So you definitely haven't missed. But it's good to ask your questions in person with the speakers. So we definitely want to see you in one of our upcoming events. And for that, you will have to do something, which is you will visit our LinkedIn page. Sorry. You visit our LinkedIn page, follow us, and you'll get the notification definitely right after we put up an event. And our website also gives you all the information of our next events, the security tour that you just missed, but all of our information about the upcoming events, our previous speakers, uh, or our attendees who you'd want to connect and maybe bring along for the next one. So I do also want to talk about today's speakers. Lana, Lana's right there. Lana, Alex, and Aruna. Aruna's a little sick. She's going to be here soon. But we are so enthusiastic to welcome all the speakers. And you can see how dedicated they are. I know one of them is sick and they just want to turn up to address the audience, to give and share all of their knowledge. So, this is today's event for May 13th. I'll have Funny address the upcoming ones, which is in June, July, and August.
Thank you, Chitra. Hi, everyone. Very good evening. I hope you had your pizza. I just need some energy. Hi, once again.
Hi.
Thank you. Thank you so much. And how many of you are here for the first time? Oh, that's a lot of fans. You will be loving our community. We will be coming up with a number of events every year. We have been working since 2.5 years almost. Once all the in-person events, you will be learning a lot, building your network, and growing a lot. So that said, we have coming up events next June, July, and August. We have scheduled the entire timeline for the year. So this coming events will be on first June 11th, July 9th, and August 12th. You can just hold on your calendar. We have the speakers, and you can get all those details on Meetup, LinkedIn. We'll be posting all the updates regarding that uh, frequently. So you can just scan the QR code as well. It will redirect to the landing page where you can find all the events. And yeah, coming up next, as Padma also already said, we are actively looking for sponsors to expand big. We are not only part of this monthly events, we are conducting once in a quarter event that are global security tour and global fabric tour as well last year we conducted in Atlanta and Dallas. Those are huge events with 1,200 plus audience. If you haven't checked it out, you can just check all of those on our YouTube. And we have coming up big events as well. Would love you guys to join that. And yeah, for the sponsorship, we are open for sponsors. Once again, if you are interested, we can collab, and we have a number of things working together. And that's it. Thank you for joining us today, and thanks for Bellevue City Hall for providing such a spectacular space. Thank you.
At that point,
Yeah.
people who came for global security too, they also participated in Microsoft Ignite. Similarly, reinvent speakers. So to attend those conferences, it costs, $2,000, $3,000. Same speakers, similar topics, zero cost here. So please, so that's the one reason that you all should come forward to support us.
Thank you so much.
Yeah. Can we have a round of applause for our upcoming speaker, Lana Fenton?
Let's make sure we can get the technology to work. We check. I can just use the handheld if that's easier.
No, this one.
Okay, so just recording. Can you hear me? I can always print.
We,
Yeah. It's not on.
this, we've kept it off so that, yeah, can you talk now?
Is it better? Can we maybe record the volume?
Flowers.
Thank you so much. Hello, thanks for being here. I want to start with a story. This was 2022 months before OpenAI launched ChatGPT, and I was the co-founder and CEO of a AI startup for healthcare called Human AI. So we were working with it's a lot of echo. You guys hear the echo? It's maybe just me. Okay, I'll just go use it. Okay, all right. So we were basically building the first LLM kind of application for life sciences, working with all the global pharma companies, and we're targeting we're working with the medical affairs team in pharma. So if you think about pharmaceutical industry, healthcare, you have drug discovery, right? These are
people trying to find something that you can actually show efficacy. You put it in human, that's the clinical trials, right? And then you go through phase 1, 2, 3 clinical trials, and you apply for kind of approval. And then you kind of sell it and you monitor patients' response to it, and that's commercial. So we worked primarily with an organization called Medical Affairs. So these are groups of MDs, PhDs, PharmDs, really highly educated individuals that dedicated their lives to kind of saving lives and curing diseases. And they sit in between late stage clinical trials and commercialization. All they do in this functionality is to use the data from clinical trials, from real world evidence, from scientific publications, and even like scientific meeting proceeds to get that insights to be able to engage with doctors, be able to guide uh, therapies and innovation drugs and trying to save lives. So we got our hands on, the early GPT model through collaboration with OpenAI. We basically put this system, the first system out for healthcare life sciences, and we were actually first to develop a RAG system because healthcare 80% of the healthcare data is unstructured. We're all familiar with this, our data nerds. So we thought, oh my gosh, we have this great system. These guys are going to love it because they're sophisticated. They understand their data. They know what questions to ask. So guess what happened? They struggled with the tool. So it's not because they're not smart enough, right? They have PhDs, all these like advanced degrees. They know their data inside and out, but they just can't use it because our tool does not work with their workflow. That's first thing. And second thing, it really does not have that context. And it does not understand like the drug names, what have you, the different across the medical, heart disease, could be heart attack, could be cardiovascular. So there are different, like 20 different ways of naming heart attack, right? There's a kind of the semantic kind of NLP challenge. And then the thirdly, I think probably most important is it didn't understand the context. So every time they ask the same question, basically from zero, right? From kind of the starting point. So we're kind of like really at that point. And this was before ChatGPT. This was before the $1 trillion AI boom, right? This is before all the craziness and advancing in AI. So fast forward 3 years later or 4 years later now, we basically, have $45 billion investment in AI. We have this huge adoption in software engineers to adopt AI to really completely change how we write software, right? This is a ramification, is the entire, not only just tech industry, is almost every single industry where people can actually use like Claude Code or Codex to be able to write their own software. But then the problem still exists, as you will see in my presentation, is we still have that gap between the end users, we call it domain experts and subject matter experts, how you ever call it, and their data. So today, I really want to kind of dive deep into this and driven by data, right? I'm a data scientist. I have a PhD in medical research. So I saw firsthand how our end users struggle with this. And then I'm going to present you with the data showing this is still the same case, despite all the transformation we've seen through like, AI coding and what have you, but that kind of enterprise AI adoption still 3 years later is the same. So I want to kind of counter that what we saw in 2022 and still is now was not our human AI problem. It's actually a general problem for enterprise AI. So my name's Lana Finn, and I'm now the co-founder and CEO of a new startup called Coxia. So I've spent the past 10 years really trying to tackle this. How do we close the gap between the end users, these are domain experts, subject matter experts, and their data? So I really kind of want to sometimes take a contrarian position, right? That's take this journey together, that what are the problems and how we fix this. Okay, I'm going to first present this paradox. And we've spent so much money on AI for the past 3 years, right? If you think about technology investment for the past 10, 20 years. This is unprecedented, right? According to Gartner, and basically global AI spending forecasted, that was forecasted in 2025. It was $1.5 trillion, right? And then, Stanford, their AI center basically said, 78% of organizations now use AI in at least one function. And sort of similarly, there's an MIT NANDA report, and I'm going to actually dive deeper into that particular report because there's just so information data rich. But enterprise generative AI, so these are LLM-based investment between those past 2 years from 2023 to 2025 was between 30 to 40 billion dollars. And yet we're still having challenges. It's like, what is the ROI for this massive investment, right? And then we can have argue whether this 95% is really accurate, right? There's some later kind of surveys and studies done that the number changes, up and down, maybe slightly lower, but the bottom line is that there's a very, very high failure rate for enterprise to adopt AI. So the NAND report basically says 95% of enterprise Gen AI pilots are stuck there, never kind of move out of this POC into production. And more importantly, they did not deliver P&L impact, so did not have a business ROI. So this study was based on 300 kind of public AI deployments and interviewing with 52 executives. And then they had basically done separate surveys with 150 senior level executives. And what is buried in this report is that based on their study, the core barrier to scaling for these enterprises is not about the model, it's not about the data, it's not infrastructure, regulation, or talent. Because the folks they talked with, they're like you guys. They know AI, they know their data, but somehow they still failed. It's because it is the learning piece. It is the gap between the end users who actually, these are domain experts, SMEs, who actually need to get answer out of their data to kind of perform business functions and the tools. The tools are too brittle, hard to customize, and hard to scale. So this is a different ways of kind of saying the same thing. So I'm presenting multiple, like trying to over-index one study, to avoid over-indexing one study. So I'm presenting like multiple studies. There's the MIT we mentioned. There's the Boston Consulting Group. They interviewed over 1,000 C-level executives. Basically found that 74% of the organization they interviewed failed to kind of scale to production. And Rand basically did AI research of all the public AI projects on the internet, found that only 80% 80% actually failed, only 20% progressed. And Gartner had, saying that, until recently, now enterprise actually start to abandon some of the initial experimentation they were doing. So there's 60% abandoned, and S&P Global last year did a survey and saying 42% abandoned their AI initiative, the experimentation. So different studies, different methodologies, and different industry, but saying the same thing. We're running into major challenges for enterprise to actually bring AI to bring value for their organization. Okay, so I'm not trying to be a doomsayer. I'm just gonna say like, what is the reality, and then how we fix this. So if you look at this, really dive into those two reports where enterprise are actually abandoning AI, their POCs, their experimentation. So what is going on, right? So in 2024, only 17% were kind of moving on from their AI. Just basically said, we're still gonna, do our manual curation and what have you. And by 2025, last year, it actually went from 17% to 42%. So that is a 2.5x increase on this. So what is like, it is going the opposite direction, right? We're seeing massive investment. We're seeing overall, executives buy-ins, and we have, software engineering widely adopting the seeing transformations. But what about these kind of enterprise application beyond software? What is going on? So if the models work, we know models are so awesome right now, and the data is plentiful, and then we have massive budget. So what is actually missing? What is actually missing? So we're looking at, the model problems are mostly solved, right? Or, LLMs are getting better almost by the week. There's this arms race and everyone's getting better and can solve most of the enterprise applications, right? I mean, we have challenges about security and all that kind of data governance and how do we put our private data into a public model. And on the compute side, we can argue like, NVIDIA couldn't meet the demands of their chips and what have you. But from the enterprise perspective, compute is enough. And then data, I mean, we're talking with the data experts here, right? We spend lots of time cleansing data, right? We have plenty of data, and it's well known that enterprise data is messy and siloed. Then we manage to kind of cleanse and reconcile and put them into like a data lake, or I have someone from Microsoft here, and then we have data Microsoft Fabrics or Databricks and data lakes and what have you. And what is really missing is the tools designed for the people who actually do the work. These are the domain experts, the end users. So what does this gap really feel like from the end user perspective, right? So I'm pulling a story from the MIT report. This is a large multinational law firm. So they deployed AI, enterprise deployment. They did the town hall to kind of got some information feedback on how what's the use case, how AI would be deployed, and then they went ahead and built it, and then do enterprise rollout. And this is the feedback from the users. It's excellent for brainstorming and first drafts, but it doesn't retain knowledge of client preferences or learn from previous audits. It repeats the same mistakes and requires extensive context input for each session. For high stakes work, I need a system that that accumulates knowledge and improves over time. So when I saw this, I was like, deja vu again. This is exactly the problem we ran into in 2022 in healthcare, right? You didn't have the context and experts to kind of ask the same question over and over again. There's no like retaining of the knowledge. You want something that kind of learns and be able to kind of become smarter and smarter. So that's a challenge. Okay, so I'm gonna kind of wrap around and just close off this with some stats, right? So we've talked about the engineering tools. I mean, huge transformation, right? In just the past 2 years, I mean, Claude Code and then the likes are just really completely changed how people writing code. Heck, I'm not a software engineer. I'm using Claude Code to prototype stuff, right? It's very liberating. But then if you look at the domain experts, the end users who actually need that data to get answers to make business impact, there's only 5%, a measly 5%, right? So these are kind of the clinicians, right? The engineers, right? It's not the software engineer, but the traditional engineers. Could be the lawyers and underwriters, business stakeholders. Really, kind of the problem still the same. No memory, no customization. Like the models can't predict consequences, and no audit trail, and more importantly, the non-deterministic nature of the models. Right? We all use our chatbots, and you ask the same question multiple times. It gives you kind of slightly different flavors, different answers. And then for enterprise AI, particularly in highly regulated industries, and that's kind of a kiss of death, right? So, so what we did at Human AI when we ran into this problem is that we had to, because in healthcare you cannot have that happen, right? You can't be putting in patient data and then you do analysis 3 times to give you like 3 different answers. Which one do you trust? So what we ended up doing is actually use humans as sort of workaround, right? So you human grounding, if there's an answer, we'll have the experts to do a sum up, kind of pin it, and then be able to kind of create workflow to bypass the non-deterministic nature of LLMs. And another thing is that, let's look at, like, is this because they don't use AI? Or is it because somehow the tools we're building are not the right tools for them, right? And then the data speaks for itself. right? Your end users, your SMEs already kind of voted, right? So if you look at this data, this is actually from the MIT study, is that they're 40%, 50%, 40% application of the if in the enterprise are adopted by your end users. But then what is happening to the rest? So they're actually using these ChatGPTs or Claude and what have you in their spare time. They're actually signing up, paying with their personal accounts. A lot of them, you probably are familiar with this. They're even putting some of their data, right, their work data into these chatbots, right, to get answered because this is kind of your users have voted, right? So this is really kind of like, because I've been in this for a long time. How do we empower the domain experts to be able to utilize AI better, right? So this is going to give us a huge clue. So I'm going to jump to kind of my second part is like, why the gap, right? Why does this exist? So I propose that there are three structural reasons, and every single one of them is measurable and fixable. So it's not doom and gloom. So first is data is not ready for AI. We all know this, right? We spend 90% of our time, like, cleansing data, QC data, reconcile data, and then spend like 10% running the models, right? So AI is very much about getting the data ready. So so this is some stats. I'm not going to go through this. Is basically how data is so important, right? But then our enterprise data is very much because it's a result of our legacy software system, right? It captures the data, but then the data is not really ready for reasoning, ready for kind of be utilized by LLM. So that's why, data scientists are really heroes. We're transforming the data and make them usable by large language models. And then the other thing is that I think we all know about this, right? Is the kiss of demos, right? We build demos, they're really, really impressive. But the problem is it's like a military campaign, right? You kind of fall apart on first contact. Once we give it to the hands of your end users, and it mostly is because of somehow it breaks because of the workflow. Right? You look at the data, is really kind of a reverse funnel, is that only 5% of the tools we build kind of reach the production, right? And then there's these the CIO basically put it very nicely, is that we've seen dozens of these demos. We've talked to all the AI companies, right? There are just so many of the experimentation and data. Which are the ones we can actually use? That's really the question, right? So the third reason I really see this is this translation, the loss in translation. And on my slide, it says translation tax. We're all familiar with this, right? Including myself, is that you have semis and describe the problem, describe the requirement, and then we have our engineers and translate them into code, and we kind of iterate. We have to do the model training, the data, and then we put it in the hands of SME. They're like, okay, now I want something else, right? This doesn't really solve my problem. We do kind of iterate this back and forth, this back and forth. So, so this is kind of the standard process. And then if you dive deeper into this, this is really actually interesting. So Boston Consulting Group basically published this, basically saying, okay, look at the AI landscape, right? The challenges and then where the factor lies. 70% is actually people problem. We've run into this, right? The change management, the resistance to change, the worry about replacement, right? Is AI going to take my job? It's all kind of human stuff. And then we have 20% is about the technology we bring and how we do that, what technology, what it fits us better. And then 10% is about algorithm. And if you look at the spending, we spent billions of dollars in this 10%, right? It's like maybe we need the kind of a reflection. We need to think about this twice. I said, disclaimer, I'm going to be contrarian, right? Um, so I really kind of want us to focus on the 70 and 20%. I'm going to skip this really quick. It's basically about putting some quantifiable values to all this kind of stats, and the numbers are pretty staggering, right? Because the bottom line is that it's really not a problem right now. It's a tool for the wrong user problem, right? We need to build the right tools for the right users. I'm going to skip this. okay, what it looks like to close the gap, right? So how do we do this? So I like to propose 4 patterns. So first is the MCP, native connectivity, right? We've all probably building your own MCPs in your organization. We all know about this. And then in my opinion, that's actually one of the keys for actually getting your AI system be able to talk with your legacy, with your existing software, existing data fabric, your existing AI infrastructure so that it is usable by the end users. And secondly, I think I talked about this ad nauseum, the persistent learning is that how the system actually understand the users, be able to maintain that memory, maintain that knowledge, understand the patterns so that users don't have to ask the same question every time, right? You should be able to ask iterative questions and be able to get better and learn. And then thirdly, I think this is probably the most important thing, in particularly in regulated industries, is how do we make our AI system deterministic? So on top of that, right, how do we actually provide audit trails? How do we create decision grade artifacts and make it regulatory ready by design? And then lastly, I think I want to be provocative here is that we talk about expert in the loop, right? Can we actually make the SME as the author, like we're saying, humans, experts in the lead? I'm going to dive deeper into that. So I might be preaching to the choir, but MCP is really kind of what makes this SME native AI tractable. And we all familiar with this, Anthropic first published this a little over a year ago, a year and a half ago, and March 2025, OpenAI adopted it, and then followed by Google. And then they collectively, all these industry players donated MCP to the Linux Foundation. So it's a nonprofit organization. And then we've seen kind of a massive adoption recently because we've been in MCP for quite some time since the beginning. We saw MCP and then everyone kind of migrated to skills. And then now everyone came back, right? This is never a single approach, right? Now we're moving back to MCP and it's a combination of MCPs plus skills and maybe plus tools, right? So, and I'm quoting kind of Jason Huang from NVIDIA said the work on MCP has completely revolutionized the AI landscape. And then I'm going to dive deeper into this, putting the human in the loop and stop putting human in the loop and we want to put human in the lead, right? So right now, I confess for our previous startup, that's what we did. We put human in the loop, right? We build a system and the humans kind of look at the answers, they do the validation, right? So the right approach is actually domain experts lead development, right? Start with, they involve from the beginning and what is sort of the need, what is the current workflow, what is the end results, and then you kind of design from there. So it's very much they drive product development.
I'm so sorry. Can I please say something? Stop. Can I present? Yes or no? Sorry. Say it. Turn the whole phone.
Sorry. That's fine. So, this is, I would like to basically, say that the next decades of enterprise AI won't be won by better models. It will be won by the team who actually kind of lead by your end users and basically put human in the lead. So I'm going to spend maybe the last just couple of minutes and tell you what we're doing now. It's not a pitch at all, but I want to kind of reflect my experience and how we can actually put it in practice and then really seeing value. So, like I mentioned, we were in healthcare. We saw success and lots of failure in terms of how to build the right tools for the human experts. And for this new startup, we're basically like, can we still focus on that, build a better system, and be able to? So what we've done in this new startup called Coxia is basically it's a self-service, and human experts can just use natural language to basically build their own AI native application on their messy data, right? This is the industrial data that is, not cleansed, it's siloed. The system will be able to just do it on its own. So, and it's interesting that we ended up with energy is because we're seeing kind of similar It's a highly regulated industry and lots of domain expertise, like reservoir engineers and what have you, right? It's and lots of legacy software. Like some of these softwares is worse than healthcare. It's been around for like 30 or 40 years, right? You have like they output their data formats are all different, and they don't talk to each other. So it's the same problem. So what we've done, I'm going to skip that one. What we've done is that we built a, think of it as last mile layer on top of the existing the infrastructure. So your end user be able to just use natural language to query through all these kind of legacy systems, right? And that the system understands, can reconcile and reason across this heterogeneous data that hasn't been cleansed and hasn't been reconciled. And the thing that really critical to us based on our experience that it has to be plug and play. If you want to do rip and replace, it's okay for the maybe first project, right? But then if you want to do it system wise, and it's going to be very, very difficult to scale. And then we build a deterministic system to really make it suitable for regulated industries and also traceable. And this is kind of a case study. So, we have a massive data set from multiple systems. This is basically your data, your wellness. You have your financial data, your costs, your financial statement. You also have these kind of a production forecast and production capture system called ARIS. And we were able to put on top of all this different data, just query, be able to identify all the inconsistencies in, whether you're actually supposed to be classified as a variable, but it's fixed, whether it's going to be non-recurring, but you're doing it recurring. So all this inconsistency in financial reporting and what have you is surfaced instantly. So this is a work that typically done by domain experts 2 to 3 weeks of work. And now we're able to basically get the answers in less than like 30 minutes. This is basically just the input. So I want to put forward a call to action, right? We're all building AI tools. We're all really great at understanding data, working with data. And I want you guys to kind of go back to the office tomorrow and saying, who is the human in the lead that I'm building for? Just do this exercise for me, right? And think about, what is the problem we're trying to address and what is their current workflow? How do they approach this problem? Can I make an AI that actually meets their need where they're at rather than asking them to adopt to my tools? So I've been trying to solve this problem for the past 10 years. And I firmly believe that more than ever, that this is going to be the unlock. This is where the next 10 years that enterprise AI is going to really see a huge value. Thank you so much.
We have a few minutes until round of questions. So questions from the audience. Do you have any? Oh, thank you. Maybe you can give us more color of how this human in the lead or SME in the lead would work, because I've been dealing with the exact opposite problem where we had SMEs designing and building their own tools for a long time. And I'm a product design manager, so now I have been brought in to fix a lot of things and just make it more consistent, make it more user friendly. So while they got kind of what they wanted in the outputs, the user experience, the usability is pretty terrible. That's not their expertise, right? So I'm just curious, like, how do you put them in the lead, but still make sure you put guardrails or help around them so that you get a quality product in the end?
Oh, that's such a great question. This is what we saw as well. We have been seeing is that you have to, yes, put kind of human in the lead, but then I think you have to take a team approach, an iterative approach, right? Not like, okay, you design all your like, your plans and your requirements and what have you, and we're just come out and build. I think you actually sit down together with them. We actually had a joke when we were at our previous startup is like getting feedback from your end users on the product is probably a really bad idea because then you have this kind of hodgepodge because they don't write software, right? Is that you kind of take their idea with a grain of salt and then put it in, and then kind of look at it holistically, see where you actually want to kind of take your product.
Good afternoon. My name is Peter,
Hi,
and
Peter.
I just like to admit that I'm not a techie at heart. So if I sound like an idiot, please do forgive me. The question is, your solution or what it is that you're attempting to do. This is different from building an ontology layer on top of your intelligence platform. I mean, having an ontology layer essentially does the same thing, right? In terms of demystifying the information that the agent is trying to work with so that it is very contextual to the use case it's trying to address. Is it something different?
So ontology, think of it as kind of a layer on top, right? So you have your kind of data fabric, right? You have all your data. You have an ontology layer, but you still have that gap between how the end users being able to utilize that ontology, be able to actually tap into that data and getting answers out of the data so that they could, right? Think about it, is we like to talk about tech, people building product, we like to say what our product does. And I reckon that we really need to focus on what is the impact of our product. Does that make sense? But they still need to, like, for example, healthcare still would be like, okay, what is my, all the physicians actually care about in terms of like how our clinical trial performed, right? Your ontology on top of layer, but still they need to be able to query all your entire clinical trial data and utilize ontology to be able to find out, okay, which patient group is actually responding better to a drug. Does that make sense?
It's essentially a precursor to your ontology layer.
Yes.
I think that's the way I understand it.
Yeah.
Thank you.
Sorry, can we take all the other questions towards the end where all the speakers are good? Thank you so much.
Thank you so
Lisa.
much.
I'm going to go with Alex. Alex, can you have a round of applause for Alex, please?
That's just on our. Can I please put this?
And then this like space here. Cool. I think this one's actually fine. Comes in the right window. I know, I'm just trying to grab the right one. It's not that. Somebody else. Where's the full screen window that I have on the side? Well, I know what it wants me to do. I think this will work. Nope, that's not the right one. Grabbed the wrong window when I did that. I have this right here, but I cannot find window in the list of windows.
In my one? On the full screen, you mean? Yeah. Can you try it?
No, because that's my speaker notes. Hmm. Try one more thing here. Yeah. I'm seeing right now.
You can see the whole screen.
See that? And then you might just go to this one. This is okay. This one. I'll just go. Yeah, I'll just do that. I can't do presenter view if I'm. I'll just do this. It's okay. All right. Okay, let me intro myself. Sorry for the technical thing. I couldn't find the window at 1%. Alex Stamen, I'm CTO at a company called Andesite. We are a cybersecurity company. So you are actually going to hear me talk about security, data, and AI all in one talk here. But yeah, so the company we have a product for security operations teams, really trying to kind of accelerate all their outcomes. Security operations is a pretty messy sort of like discipline for any of you who have seen how a security operations center works or worked with security operations teams. They're constantly dealing with blinking lights, incidents, things like that all the time. It's really ripe for disruption, I would say, in the AI space. There's a lot of kind of just inefficiencies in terms of how they look through data, being able to assess the impact or risk of something. And so that's kind of some of the problems we're focused on. We do a lot of work in US government, as well as other regulated industries. That's actually one of our big focuses. So yeah. I'm going to talk about, we're going to start talking about data architecture here, specifically for cybersecurity. And kind of like how modern security architecture kind of needs to have a bit of an overhaul to get the most out of it. So yeah, so that I can kind of get a sense of what you guys all understand. Who all knows what SIEM? Who all knows what that is? What is a SIM? Okay, so we have a small set of people. So I'm gonna as I'm going along, this talk is a little bit cybersecurity centric. I will try to make sure I explain what some of these terms are and what some of what things I'm referring to. SIM stands for Security Information and Event Management. This is effectively like, for those of you who might come from the other world, this is sort of like your observability store. This is where you put all your log data. Okay. So very common thing that we hear when we talk to CISOs all over is, hey, my SIM is too expensive, but I can't do anything about it. So what they end up doing is they end up just complaining about it over and over and over again. I pay too much money to Splunk or Elastic, whoever it is, and they just complain about it every single year while they keep increasing the budget because they're logging more data, right? So we're going to talk a little bit about how did we get here, and what can we do about it. So to talk about this, we need to rewind in time back to like early 2000s timeframe when cybersecurity was just kind of getting started as an industry. A few products were coming out. Really, the way you kind of dealt with large amounts of data was via a relational database or some type of database, and you typically had a database admin. Okay, so they would move all the data into one spot and say, here you go, business worker, here's your data. As it turns out, relational databases and SQL-like syntax and things like that, number one, not the best way to store cybersecurity data. A lot of cybersecurity data is not best represented that way, especially like application logs. Dumping application logs into a SQL database is not very useful. Security analysts, so the ones who are sort of like the SMEs or the domain experts in the area, I hate SQL. I've had arguments with the ones I work with about them telling me SQL is so awful to work with, and me responding with, I think Splunk is actually worse than SQL, and I don't. So, anyways, it's just a bit of a gap in the domains that we work in. There's not really a right or wrong on it, but yeah, it's just not really made for them. So then what happened is, companies realized this, and SIMs started to emerge in kind of like, let's call it 2005 timeframe. So this is where you get companies like Splunk, which is a very popular SIM. And what these companies did is they said, hey, not only are we going to kind of give you a place to put your data, but we're going to give you a much better interface to work with so that your experts and your analysts can work with the data. One thing a lot of these SIMs got right is they do some sort of data transformation and processing type things without exposing you all to exposing the analysts to the complexity of having to do that. So a lot of a simpler interface, but is definitely a kind of like an all-in-one analytics platform with a data architecture built in, okay? So then what happens is our world of security gets more and more complex. Now we're dealing in network endpoint data. Cloud comes around. Finally, enterprises start moving to cloud, and it's like, okay, oh my gosh, like now all my cloud data looks all different than everything else I was doing before. Complexity increases, threat actors increase in complexity, more and more tools come in the cybersecurity ecosystem. So what does everybody do? Everybody takes that data and they say, well, let me put it in my SIM, right? Because that's where we use data. Well, now the SIM is this bloated beast, and we just have a fundamental architecture mismatch between what the SIM was originally intended for, which is a lot of application logs and maybe firewall logs, things like that, and all the different types of data that we want to work with, okay? Um, and I don't want to throw too much shade on the SIM. It still has a great purpose in life. Medium scale event logs, still very excellent for that. I don't see the concept going away completely anytime soon, but they think there's a lot more we can do when we kind of go back to some of the fundamentals. So just to hit what modern data kind of looks like and why it doesn't, quite fit the paradigm as well. So let me start with endpoint telemetry. Thanks to Microsoft and CrowdStrike and things like that, we can now collect lots of data from your device endpoints in your enterprise. But it is a lot of data. Like if you want, you can get gigabytes per day off your device, from file information, registry information, network, all kinds of things. You often don't need much of this data until you really need certain parts of it as part of like an incident investigation or things like, or maybe you're triaging. So a lot of that data gets unused. Cloud audit logs, likewise, very high volume. Interestingly, the schema for these changes pretty frequently based on what's going on, and I'll show you an example of that in the next slide. Data is very highly repetitive. There's a lot of like, so and so accessed S3 bucket and did the right object operation. It's just filled with that, right? So it's kind of like a very boring, like repetitive log. Network telemetry. I'm not sure if any of you've seen what NetFlow looks like, but if NetFlow is sort of like let's call it one step up from packet capture. So it actually deals in like, connections between two devices and just trying to capture like, okay, this device talked to this device. This is how many bytes were sent. This is the protocol and things like that. If you actually record that data, that is a absolute ton of data. It is a ton of data. So it's not really something you even like look up one record for. You typically would run some aggregations and do some analytics that way on it for it to be useful. Maybe something, time series. Yeah, identity and SaaS information, even just tons and tons and tons of metadata. A lot of times what's interesting to do here is to actually relate, because now you're in the identity world, so you're often looking at the relation between these identities or what they were doing. So the nature of how you analyze it's a little bit different. And then really on the other end of the spectrum, you've got like email and communication. So if you think of emails or Slack messages or things like that, like dumping the text into an application log store and trying to do analysis on it, it's not super useful. A lot of times you want to do some pre-processing like NLP, maybe put it into a graph database, all kinds of things you want to do, but like, yeah, definitely not fit for the SIM. So yep. Just a quick look. What does an evolving schema look like? I think you guys, being data experts, you guys probably understand a lot of this stuff. But so CloudTrail events, this is AWS is sort of like audit logging of things happening in AWS. This is what it looked like in 2022. This is what it looks like in 2025. So in security operations, what will happen is they'll have like detection rules and ingest rules that run based on the schema of some particular thing. Schema changes. Now information is no longer showing up because like in this case, like user identity was represented as one thing. Now it's represented as something else. The discipline. So for a data engineering team, most true data engineering teams would have things that detect things like schema drift. Security operation teams are not filled with data engineers. They're not ones that are like really experts in like, how do I set up an alarm if something changes here? So what ends up happening is their detection rules go out of alignment. They stop ingesting data. And then somebody like 3 months later is like, oh, yeah, we're not really getting these properties of this user anymore. Oops. And they're in the middle of an incident, right? So lots of problems. Okay, so let's talk about what I call the SecOps doom loop. The security data architecture and a lot of security stuff is very reactive, very, very reactive. So what'll happen? Okay, we've got a blind spot in our security data. What do? I go buy another tool. I was like, oh, this one company has this tool that like gets this data from me and they process it for me, right? So I go buy another tool. So now I have a new data silo. I need to put it somewhere. So I put it in my SIM or I bring it into something else. And now my costs start getting high because the volume of all my stuff is going up. So then what happens is I come up to my next budget cycle. The board and the CEO are yelling at me because everything's so expensive. So now I got to start dropping stuff. Now I lose visibility and now I'm in a doom loop. I just can't get out of this loop where I'm constantly trying to add more data and then realizing it's too expensive. Which is this is going to be pretty natural. I mean, we're increasing the complexity of all the technology we're using in enterprises. So this is naturally going to increase, but it's increasing at such a fast rate, and the amount of spend is increasing at such a fast rate that it's hard to rein all this in. And it's really, really hard for CISOs to think about okay, if I buy any one tool, how much is this helping? What is considered good, right? It's easy to know when you've been breached, but it's hard to know for any one decision you make in here, what is the net impact to my risk? This is actually one of the biggest problems that a CISO buyer has. And we face this as a security vendor company. There's a lot of work we just have to do to give them the economics of the thing we're trying to give them, because it is really hard for them to reason over how much risk am I reducing by buying stuff. So if you want to see what these costs actually look like, this is kind of reality. And I can tell you, I do know of one very large enterprise, that technology company, where their Splunk bill is upwards of like $50 to $70 million a year. They pay Splunk $50 to $70 million a year just to store data in Splunk. That's not even their entire cybersecurity spend. That is just Splunk. Okay, so this is expensive. And again, reminder: these are not data engineers. They do not have teams of people that are optimizing all the things they're doing. So oh yeah, and on top of that, telemetry volumes often increase. Telemetry being a very generic term for just data coming in from whatever, whether it's endpoints or anything like that, increases 20 to 30% per year. Their budgets are not increasing 20 to 30% per year. I believe the number we typically have gotten from folks like Gartner and things like that is around 16% is what their budgets tend to increase per year. So we have a little bit of a disparity, and they have to continue to look at how do I prune tools, do things more efficiently. On the detection end of things, so this is sort of like all the logic you run to try to detect, that, hey, an alert should fire and I maybe should go investigate this thing. It's really challenging in the industry right now. The speed at which criminals and threat actors are moving is incredibly fast. So, you see even from 2021 to 2025, we're down to an average breakout time to 29 minutes. Breakout means from the time that they first get into the environment, compromise something, to the point at which they move laterally in the environment. So it's like maybe I just got privileged access to this device, and now I'm going to move over and grab something on some server of yours. So that's what movement means. It used to be the case that a lot of intrusions were tied to malware. So it was like you were just scanning for malware on people's machines. Well, guess what? Most intrusions do not involve malware anymore. Account compromise and things like that, super, super common. Like all I need to do, so I don't need malware. If I send you a message with a link that looks like a login portal and I take your username and password, I don't need malware. I have your credentials. There's a lot of stuff I can do to hide in the noise of your environment at that point. Kind of game over, right? So on the SIM end of this, we tend to write detection rules. They have some built-in detections. They are pretty good at doing running rules against your existing data and matching certain patterns that are known. What they don't do incredibly well is detect the things that are unknown. So techniques are evolving pretty quickly for actor groups. Part partly due to a lot of AI tools, but even without that, they're just evolving very quickly, and it's hard to sort of detect like behavioral anomalies and things like that just inside of your security data lake. And so what people do is they'll follow like things that are published by threat intelligence sources, and they try to replicate that in their environment. Say, here's how I'm going to detect what I know this threat actor does, but I'll detect it in my environment using these rules and things like that. But it's really hard when you're a quarter behind, just trying to catch up to everything that they're doing. Oh, did I jump? Oh, sorry, I had a few slides ahead. Okay, so we've talked a bit about the problem. Let's talk about the solution. So I think we've kind of already established like one, there isn't one like silver bullet solution for all the things you're trying to do. I've listed 3 categories here. One is real-time triage. This is like I get an alert and I need to figure out what to do with this alert. What's interesting about this is, let me give the example here. So it's like you get an alert that someone has failed their MFA password 5 times in the last 2 minutes, right? So then that fires an alert. Security operation team's like, okay, let's see what's going on here. The type of data analysis that they do for this type of triage is really, really primitive. Like it's not like very extensive, complicated queries and joins and things like this. It's like, go look in this system, go look at this user account, grab this thing, go over here, look at this other system. Okay, and then yeah, the person's not out of office right now, so this kind of makes sense, right? Like they're kind of just hopping from tool to tool with a bunch of very simple queries. Long time frame hunts. These ones are very interesting because the complexity here is a little bit more, not very complicated analysis, but you really do a lot of searching over very, very long amounts of time. So why would you do this? You would do this if you started to get signs that potentially something has been in your environment for 6 months and you want to know how to get in there. There are a lot of, especially nation state actors, that will go into environments and live in there for very long amounts of time, almost completely undetected, until they decide one day, okay, now we're going to do something, right? So this is a thing this is a common thing you'd have to do there, is go back through a very large amount of your data. Also, threat actors know that it is very hard and expensive to store all the data for this long amount of time. So one reason why they sit around for a very long time, one, it's easy to not be detected. Number two, it's actually, they know it's hard for organizations to go figure out how did they get in to begin with, because the data could be a year or so old, right? So it's a very hard thing for them to kind of figure out. And then just optimizing your detection rules. So these are just kind of 3 different workflows that people end up having to do. So when we think of our data, and this is not an exhaustive list, but when we think of our data architecture, we have to kind of think about all these different use cases and how do we make it optimal. Great. Moving on. So call this like the modern security architecture. Let me start describing this just kind of from bottom upward. So you've got your event, you've kind of got your data sources. This can be anything. This could be data from endpoints, firewalls, access management systems, identity management systems, could be even open source intelligence. So things going on in the world that get published. There's multiple places you can put these things. You're always going to have a data warehouse, right? Something that deals in like hot and cold storage. Inside your data warehouse, you may have different ways of storing that data. So you might even have, for certain types of data, you might run it through a data processor. That's what's on the left there. Oh, wow, this shows up really dark. Sorry, this is much brighter on my screen. So yeah, I'll just kind of, on the left there, data processors, you might pre-process some of your data into a graph-like structure and put it in a graph database. And now that's part of your data warehouse. It's potentially easier to run certain types of queries that way, but you don't need to do that for everything. So maybe some things just look like event logs. But this is where you would want to manage like hot and cold storage and really be cognizant of the cost of storing things that you need to access quickly, because you don't need to pay for everything to be accessed quickly. And then on the right-hand side, what we have is we'll call federated data sources. So this is things that you might use to look things up during an investigation. So for example, binary hashes. Like a binary hash is not something you need to store alongside every single binary you capture, but when you're looking at an incident, you might want to go cross-reference with a binary hash. We can leave that data where it originally is and just grab it at runtime. Or at query time. We don't need to have that all in my data warehouse. So if you think of things being organized this way, then you layer on top of it all your human analysis, any machine learning you're doing, text engineering, all of that, all of the actual type of analysis and decision logic that you want to follow. It can reach into all of these sources of data. And then above that, the layer above that is what I'm calling the SecOps UI. So this is the pane of glass that the human actually works with, because in the end of this, we're still going to have a human kind of what we actually at Andosite call at the helm, similar to, I can't remember the other term that was used earlier, but yeah, we call it human at the helm. This is their pane of glass that they work with to interact across all of these searches, which may be federated, they may be not federated, but it doesn't matter to them. It's a unified system that's very simple for them to work with. One of the challenges with all this sort of like federated type searching in current security operations is a lot of times, like an analyst may have to deal with multiple query languages, or they have to pull up 3 UI tools, and they have 3 UI tools all open on their desktop, and they're switching between all of them, copying data around. This is what creates the headache. But if we can give them a singular UI over the top of various different query languages, various different APIs, then they can just work through everything as one sort of very fluid system, right? I'll watch time here. See, okay, I'll speed up a little bit. So just four shifts that I think we're already starting to see now. Used to be one data store for everything. Now we're having multiple data stores, not like no vendor lock-in, things that work over the top of different data stores. Used to be ETL everything in a SIM. Now there's a lot of movement around zero copy, leaving data where it is and running federated searches. Pushing more processing down to the edge. So that is things like, on your endpoint systems, maybe doing a little bit of data pre-processing at the edge before that data even comes off of your endpoint device. That is a form of that. I actually have another slide on that topic. And then classical cybersecurity has been rule matching as the kind of way that you dealt with detecting things. And I think we're now moving towards more of a decision layer where AI works across the top of all of these different data sources and correlates it all together. I would like to point out, I have gone 25 minutes or 20 minutes in this talk, and I did not say the word AI once. So now we will talk about AI. I think it's really important to talk about the data underneath AI first and get that part right. And then we can talk about where does AI sit with the humans that work with the data. We have all these pieces today, and now a lot of it is just really about getting the workflows right, as Lana was talking about, and making all these integrations more manageable. I'm gonna skip over this a little bit. The only thing I want to point out on this slide, real quick, you can read it if you want, but as it turns out, like, most of the security signal you need is in 20% of your data. A lot of it is not used, and a lot of security teams just don't have the ability to understand what is useful and what is not. This is another thing that I think AI is ultimately going to be helping us with, is understanding this type of data has led to these outcomes. This other data has never been used for anything interesting in your security operation. You can probably just push that directly to cold storage. Rather than even ETLing it anywhere, just push it to cold storage, keep it around, maybe for historical archive reasons or for auditing reasons, but you never using it, so don't pay a lot of money to keep it warm. Okay, how does AI help here? Number one, query languages. So like putting data in a lot of different places. So let's say you're trying to like do some analysis that involves pulling data out of a graph database and something out of a, some other type of database. Well, now you're learning multiple different languages. This is something really that generative AI is really great at, is helping people write in these bespoke query languages. You would not believe how many companies have built DSLs for their product, domain-specific languages for their product. Every time we build a new integration for one, I always look at their page. I'm like, oh, look, they invented their own DSL now, right? And so but they only are solving a very specific problem. AI can really help you work across all of these different languages without exposing all that complexity to the user. Inconsistent schemas. So we actually deal with a lot of this in our product, where people don't log things like the same way in all the places, right? And so we have to do some interpretation of that. with with sort of the enterprise providing a little bit of context on where the data came from, what does this mean and what does that mean and how do we name it like this or whatever. AI can actually take a lot of that and just kind of like without you having to do all the data normalization work, can kind of interpret what you mean by the data you have. We actually have some product features that do this, and they work really well. Last thing is something I mentioned earlier, which is about just kind of helping you optimize how you store your data. And the product we built, we're just doing the starts of this right now, but I actually think the future is going to start to look like, the system's actually recommending to you, hey, you're using this data a lot, and your queries are taking a long time. If you actually store it more like this, it's a more efficient way to, you'll be able to retrieve that information faster when you're doing like a security operation. Yeah, so just calling it out, I'm talking, as if this is just kind of like, hey, all this stuff is here and now. This stuff's all really hard to get right. There's a lot of things around governance and access that teams have to work through. Trying to move over to this world, very challenging. Operational complexity. So when we're talking about a more complex data architecture, we're talking about more points of failure. I think my view on this is that, I just showed you the amount that people are already paying for their SIM. Imagine you can get that cost in half, and you have a very small team of people that are savvy in data architecture, kind of helping to manage some of the complexity there. You're probably going to, in the end, save money just from doing that. Very simple, kind of like 4-step plan, if you will. How do we break out of the cycle here? And this is mostly about saving costs. So try to find the data that's having the least detection value, push it elsewhere. This is where products like Cribble and stuff are really starting to make headway in the marketplace. Cribble kind of figured out that people need to find better ways to push data into cheaper places. So they've built a whole product around that, including their own data lake and stuff. So yeah, move it elsewhere. Start to think about the tiering of the data better. Federate the access to it. This is really where AI comes in to help you with searching across all of that data in a federated way. Then go back and try to reevaluate what your SIM budget really should be, or your budget for all these different data tools. And last slide, and I'll transition any questions. One thing to kind of think about just from the security perspective, what you're really trying to do is you're trying to say like, okay, I've got as a CISO, I've got the budget I have. I'm trying to reduce my enterprise risk as much as possible with the budget I have. And so by building a better sort of like data architecture underneath all of this and bringing better tools in, you can actually do more. Like, your analysts can investigate more alerts, or they can cover more incidents faster. And so by doing all of that, you're really just reducing the risk which pushes the curve to the right, given the same amount of budget. And that's really what our goal is. Our goal is to get CISOs to reduce their risk as much as possible for the budget they have. And yeah, so this is where we think the focus on adopting modern data architecture and security operations, and layering on top some really solid AI foundations and AI products on top, I think we'll kind of achieve this outcome. So. Oh, yeah.
Thank you so much. Any questions? Just 2 questions for now, and then we'll address.
Is there a way to be selective about the data that gets stored in the SIM?
Yes. So, like a lot of times that's so whatever kind of like your ingestion pipeline is sort of where you would make those decisions. And that's where, like, I don't know if are you familiar with Cribble product? Cribble. But yeah, that is a product that does help with kind of like being able to take data from multiple places and route it to like various different places. You really can choose that as an organization. You can choose to like put whatever data in your SIM, or put it. What's happening now too is some people are just putting it into like S3 or Azure blob storage, and then layering over some of the tools on top that allow you to go do rapid search on top of it. So yeah, people are starting to do that even now.
Hey, thank you so much. Quick question about the agent security. So are you guys getting the logs from the agents as well? Because a lot of the companies are deploying agents now, getting the logs from agent. And how is security operation team managing that? Because it's a new
Good question. Yeah.
attacks, right?
Yeah. No, this is a good one, and we've talked about this a lot internally. Um, these companies are just now starting to kind of get on the agent security bandwagon. And so they're looking at things like they're really almost more in the governance and compliance part of this right now, which is just like who gets access to what, whatever. In terms of the operational side, like monitoring, it is really early stages and they are behind. Like we have hardly talked to a security operation team that even knows how they would monitor agents at all, right, in their security operations center. So I have not seen that. I haven't seen that really take off in security operations yet. I would expect in the next 1 to 2 years, they're going to start getting pressure by their boards on like, hey, there's all this stuff going on. Are we monitoring this? So I think probably in the next 1 to 2 years, we're going to see a lot more of that, but it's very, very, very early stages still for it.
Thank you so much, Alex.
Yep.
Yeah.
I just turned it off just so it didn't click around.
Can we have a round of applause for Arina, who's our next speaker? To address one point before we hand it over to Aruna. Anybody here like looking, taking pictures of the presentation or any information that you're sharing on LinkedIn, we would please request you all to tag us with the Seattle Data AI Security to help us keep in touch with you, invite you to one of our next events. It's just we want to spread the word, and that's one only help that we could ask from you. So please tag whoever you met today during networking, tag all your friends to the post. We will try to tag how many ever we can today that we've met and spoke to, like even when I spoke to you. That is one quick help that we would request from all of you. And the other thing is anybody who's interested in scholarships or volunteering or anything, any sort of thing, please reach out to us. We can have a quick chat with any of the team members, me, Fanny, or Padma. And yeah, we can definitely make great collaboration. Thank you so much.
But with respect to volunteering, it doesn't have to be time intense. For example, one of our big pain point is we want to, when great speakers come, we want to fill the room with good people. So most of our energy goes in outreach. So it is very easy if we have volunteers who says, yes, Padma, these events are good. We really think that this kind of a community should go. If so, want to be tagged, hey, we will forward it. We will forward volunteers. We'll be happy to tag us, we'll do it. Simple 1, 2 clicks, so please see us. Thanks.
Thank you so much, Padma. Over to you.
Hey everyone, this is not how I usually sound. So I have a cold actually. I thought I got over it, but it looks like I still have it. I'll keep this here if in case I cough.
That's for recording.
Oh, is it? Okay, go ahead. So bear with me if I cough or I get a crack on my throat. No worries. All right, so I'm here to just share a couple of stories. No big funda, the things that we experimented with and the things that we learned and what we're trying to avoid the mistakes that happen in our projects. Before I start, I would like to understand who are developers here. Raise your hand. Awesome. I love that. So, what IDEs do you use? Like, what AI coding tools do you use? Cursor. Oh, Cursor is just one or two? How about Claude? Oh, okay, I see why. All right. So, our company also uses Cursor and Claude Code majorly. And I'll share the experience. All right. I'll be focusing on just two aspects of cost management. One, how to use AI coding tools in a cost-effective way. And the second one is how to build AI agents that are cost-effective. These are the two areas which is consuming a lot of money these days, and it definitely makes sense to talk about them. So first one, the first story, last year we signed up with Cursor because everybody wanted AI. So we were like excited. We went to Cursor, got a great deal, and we used it for a year. We onboarded all of our engineers on Cursor. And this year we had to renew. We went to Cursor, hey, we loved it. Let's renew. All right, we changed our billing model. Last year it was request based, now it is usage based. Okay, no problem. Can you tell me what would it cost if we switch to the new model? Take the usage that we have had. We were under 300K last year, and the projection was over 1 million. That's when we were like, oh my God, we did not budget for this. How did it happen? There was no way we cannot continue to stay in our old model. We definitely have to move to new model. So we buckled up, we went ahead and spoke with a bunch of companies, Klein, Augment Code, Google Anti-Gravity, all the tools. We weren't happy with anything. Our developers wanted either Cursor or Claude. The same usage when we projected in Claude with the current subscription model that we have, it was way over $1 million. So we had to go with Cursor. Now we have to think about how do we optimize cost? Something that was unlimited, readily available, all about excitement, push the code to production. Now we started to think about, okay, what do we do now? Like, how do we make sure developers use the tools in the right way? So those are the tips I'm going to share now. I told you guys the story. So first, I realized there was no modern governance. We never restricted anybody from using any models. So what developers did, used Opus models, the best of the best. They didn't even look at IQ and Sonnet and GitHub Copilot and all GPTs. No, it's always Opus. And that was costing us a lot. So now we do ask, do you really need Opus? Are you a developer? Are you working in a critical project? Then you have access to Opus, else please use Sonnet, right? So we do need model governance because we don't have unlimited budget for these. And the second one is we trained our developers to use the right set of models. For example, I said you don't need Opus for everything. Every model has its own personality. Some are good at reasoning, some are good at doing the planning, some are very good at following the instructions. So in that case, we had to instruct, we brought in folks from Cursor and then walked them through what exactly that we can do so we can reduce cost. They said use GPT models for planning, use Opus for execution. That's what they do within their company, and they have seen better results. So we try to follow that. And we also started to track the lines of code accepted and also merged. Even now, we're working with other products like Claude with GitHub and then Cursor with GitHub to understand, yeah, you guys are writing code, generating lots of code. Out of that, you're accepting certain percentage of code. Out of that, you're pushing a very less percentage of code. What happens? It's a funnel. We don't want a funnel. In an ideal world, we want a pipe, right? It's a single linear pipe. So what happens is, like I saw a developer with 20,000 lines of code, 12 accepted, no PRs created. What were you doing? So these are the questions we started to ask. Are you not prompting well? Are you not using the right model? So we started to ask these questions and bring in those developers who were using the IDEs effectively and started to share the best practices. How are they able to get to 90% acceptance rate while some folks are like 10% acceptance rate? So we realized some use really good prompting. Prompt engineering helps a lot. Instead of just assuming, okay, I'll just do the prompting at a high level and make the models think and figure them out. Let me see what the output comes out. And then I'll prompt over and over and over and over again. Yes, it is a costly operation. The end of day, it's going to go over the context again. And it's processed, and every single thing is costing tokens, and we don't want that to happen. So all you're going to do is invest in writing that very good prompt. Give specifics, give which file, what exactly do you want, what output format you want, what input is, like set the guardrails for the inputs. The more instructions you give, the better it is. So and lesser iterations, and you get to finish your work and then go home faster, and also spend less money. On Ghost licenses. So in some cases, we started with 500 plus licenses on Cursor. When we audited, there were at least 70 to 80 folks who were using under $10, while we were spending around $70 on them per month. And we were spending more for overages. What we call as overages is you have a commit, and then beyond that, if you go, it's an overage. And we were, hey, we are spending $70 on you. You're not even using the tool for $10. Do you still want to be here? Oh no, I just was excited. I want to try out. I'm okay to move. We weren't asking these questions and until we heard that $1 million. So now we constantly track who's actually using and not using. We go back to them and then ask, do you still need it? There are a few cases they were on vacation. There are a few cases where they were still experimenting with a few thoughts and experiments. They were just in meetings, so they were not coding. So we consciously went to teams and then checked. So we have made that into part of our culture now. So these are something that we could do immediately. So we removed unused licenses. We taught our engineers to use the right models. And also we tracked dashboards. Claude or Cursor, they give you a good dashboard with the usage of how many lines generated, accepted. Now it's getting to the merged number of lines of code. I know NVIDIA says token maximizing, like use as much token possible, but we are not NVIDIA. I don't think many companies are NVIDIA. It's not about just using the tokens, but using the tokens in a right way, making sure that you're getting the best out of your bucks is our goal. And then use plan mode before you start executing. You tell exactly what's happening. It's like your buddy, right? Hey, what do you think? Oh, it's going to happen. Like you tell, like these are the steps I'm going to do. Oh, that's not what I was saying. Go ahead and change. Even before you write the first line of code, you have an option to change what will happen. So you save a lot of money there. I mean, every employee of a company should consider this as your personal pocket money. That is how you'll be able to optimize what you're spending. It's not an unlimited source. Companies are just your bigger home where you need to budget, right? And especially in this economy, it's very important that you consciously spend your tokens. And we value those developers and we bring them in, make them heroes and make them talk, share best practices. We even give them DX championship, badges to them. All right. So the recommendation we usually give is if it is just a very simple, not so complex logic, then use Haiku or Sonnet is feature development, refactoring, and debugging, and Opus for system design, security review, and complex algorithms. Everybody was talking about security. It's very important that we don't make mistakes. We use the best models possible. This is just a suggestion. So you guys can do your homework and see what model best fits for your use case. So some of the engineering thing we did is Claude MD. I'm going to talk in terms of Claude because I see a lot of you are Claude users. Use Claude MD for context. So give it as much information as possible and also as narrow as possible. Don't give an entire repo. Imagine you just go and read an entire repo for a simple question on a file. You change the context and use a shared skills library. As a developer, if you have a skill that has worked for you, share it with the rest of the organization. We own the central repository for the skills. So all of our developers publish there, and then we share it with the rest of the developers. So you don't have to reinvent the wheel. You can share the best practices. And skills is an amazing way to execute something that's repetitive. And human in the loop checkpoints. So this is something I learned from one of the developers when we were talking about cutting down the cost, and he was using his personal, I mean, not personal, like he was using our something we call it key, API key, and we track them very closely how many tokens are used. So now I saw everybody was becoming conscious about the usage. So he initially, before we brought in all these rules, fire a prompt to Opus, go for a coffee, come back, check. That was the norm. But now he said, Aruna, I don't do that anymore. I tell Claude, hey, don't generate more than 1,000 lines of code. Check with me before you move on. Because if those 1,000 lines of code is not what you expected, you can go back and change. Imagine you come back and 10,000 lines of code created and all of them are trash. Everything is a hallucination. You have to regenerate everything. So this guy said, I have instructed, don't do anything beyond 1,000 lines of code. Now I come and check. I give a go. Then I generate the next set of line. It is slow, but I'm saving money. I'm staying within the budget. Then we actually made that as a standard to rest of the employees. Do that. You do need humans to verify. Don't just run everything, assuming everything is going good. Come back and say, oh, it's not looking good. Do it again. Eh, That luxury we don't have. Now, as I said, we are also tracking acceptance rate. I said like thousands of lines of code generated to few lines of code accepted and no PRs generated. We are going to closely track. I think all companies should do that. So that is where we will see where the problems are and educate the developers to do the right thing. So prompt caching, this is some of these optimization strategies we did. You can cache your prompts, so you don't have to repeat the same indexing again and again. And context window, context is very important with models. As I said, do not give an entire repo context when you're questioning about a single file. So make sure your context is narrow. As you know, every session is like um, Claude does not remember what you did at like the previous day. Every session is different for Claude, right? It's like a short-term memory person. You have to keep giving. This is your context. This is where you need to work on. So you might have chatted with Claude and you both collaborated and developed a product. You close the session, come back. It doesn't remember anything. You have to tell exactly where you were. And in order to do that, it has to do that indexing again and again and again, right? So if you have to do that over and over for each of the session, make sure you give the proper context. Don't give too much context. It's going to go and learn a lot of things while you're actually going to work on a very narrow thing. Like just I said, like, and don't give an entire repo as a context when you're going to work on a single file. So this is very important, and this is one of the areas we could save a lot of money. Another thing we did is token budgets. So we started to track each of the features against a budget ID. So now if you're going to an LLM, we have an LLM gateway, and every feature request has to go with a budget ID. So let's say you're working on a critical project versus something that's so not critical. We would see how much money has already been spent. We would say $1,000 for this feature, and then if you exceed, then it goes through approval processes. It's just a way of keeping the tokens under constraint environment. Yeah, output length discipline, which I already spoke about, like don't generate more than certain lines, so we can get back and then change course of action if it's not something you're looking for. Iterative refinement, as I said, it has to go through iterations in small chunks. So you have a quick feedback loop. All right, so this is quick. That's one story. So we, after doing this, I saw developers being very conscious about the token spend. They're using the right models. We are also tracking the budget against each of the features, so we know where to spend and where not to spend. So we're very observant and reactive to how the tools are used. And also, we don't give both the tools cursor. If you have Cloud Code, you don't get cursor or vice versa. So there are certain constraints. It will be different for your company, but these are some ways that you can restrict the money spent on AI coding tools. All right, AI agents. This is another story. This is not about AI coding tool. We are writing a lot of agents. How many of you have written agents here? Awesome. And so this story is about an agent. Did I introduce myself? Or did I start? Oh my God. I I'm a senior director at Upwork. My team leads developer enablement services. That means anything as a developer you have friction, our team comes in and then helps unblock that friction. So we write agents for developers. If you guys don't like documentation, we write agents to help you with the documentation. If you don't want to wake up in the middle of the night to attend to an incident, we write agents to go over the logs to detect those incidents. So we help developers. So as part of that initiative, we came up with something called document generation agent. So we usually run a developer survey every 6 months. And one of the top most commons was, of course, build and test. They're not happy. And the second one was, I don't find the documentation. Even if I find the documentation, it is stale. So we thought, okay, why don't we write an agent? Let them write the code. We'll read the code and produce the documentation, at least something off of the developers list. So we used Goose. How many of you have worked with Goose? Okay, you're only one. Okay, you're going to change your mind after I talk about this. So Goose works on a recipe base. So what's a recipe? It's like you're a chef and you have a recipe and you cook with it. It's a very high level English language that you instruct the models on. So we were using Claude Sonnet. At that point of time, our complete focus was improve productivity, help the developers, get the documentation, get it accurate. That's it. So we generated the documentation for T0 and T1 services, and we are not service owners. So we went to the engineers, hey, you guys are owners. Can you see if our documentation is good or not? No, most of them were hallucinated. You guys are not documented dependencies. This is not right. That is not right. All right, let's see what we can do about it. That's when we saw we already spent $15,000 on, and no documentation was useful. And this is not going to work. We are not spending another $15,000 and then go to engineers to find out, oh, you have improved, but it is still a hallucinated document. Then I came up with this three-tier architecture, which I'll present a little later. The same thing, another agent which goes through the application logs and detects errors before it becomes an incident. We were happy, we ran it over a weekend, $2,000 just over a weekend. All right, turn it off. Let's see what we can do about it, right? So we have shut it down now. We don't have bandwidth to revisit, but we revisited the document generation agent. So this is a three-tier architecture. So for agents, what we were doing earlier was a very high-level prompt sent to an LLM and then seeing the response. That is what we were doing. There was no architecture behind it. We tried to switch Claude Sonnet with an open source model. Open source models, as you know, it's way cheaper. So we tried with Kimi, we tried with GLM5, we tried with DeepSeek, and all the list of open source agents that we could find. We couldn't just switch because they did not understand the high level prompting that Claude was able to understand and reproduce. They needed a lot more hand holding. So and beyond, we at some point of time we couldn't just write any recipes. Then I thought, okay, let's just trash it. This is not working. It's just beating around the bush. Let's architect. So let's engineer in such a way that if you're reading a document, if you're reading a code and generating a documentation, there are multiple steps involved, and many of them are very deterministic. Go get a user authenticated, open a file, read a file, see if the source exists. What is generative AI in it? It's a very deterministic step. It could have been just a programming language with if and else and just open a file. So I asked my team to identify deterministic step. And apparently 60% of what we were doing was deterministic. So, and then we used LangGraph to do the programmatic way of executing these tasks. Then we deployed open source models, which is reading the code and generating the documentation. And for Opus, the frontier models, to do an eval if it mattered, if it the quality levels were okay. We did that, and then we sent the documentation to the engineers again. It was a lot better than what we had earlier, and we spent 20x compared to 20x lower than what we spent earlier. So it was a big hit. And we shared this architecture with the rest of the org for them to adapt. So it was a very simple solution. It's just about architecting, understanding where you use generative AI, where you use the deterministic aspects and write it as a program. That's all it mattered. So we are still using open source models. We ran multiple open source models. We finally landed on GLM5 as the best option for us. Again, so every model has a personality. So you guys have to go through, dry run, and then see which model works for you and pick your best. So for us, GLM5 worked, and we are sticking to it. Maybe if we start rewriting the issue detection agent I was talking about, maybe another model will work better. So it's just about dry running, doing a POC, and understanding what are your success metrics, and then defining, okay, this is where it stands, this is high ranking, and then pick that model and then push to production. So that's what we were doing. So we are uh, using frontier models very selectively, only for those purposes which really matter. Otherwise, deterministic and open source models are really, really awesome. So if you guys haven't tried open source models, I would say just go ahead and try and give it a go. They're not bad. It's just they need a little more hand holding. And I think for scalability purposes, it's okay. It's a good investment. I already talked about 20x cost reduction. So now coming back to the question, we are talking about AI a lot. We talked about the lines of code generated. We talked about all these agents that we are running. But how are we measuring the ROI? Are we really benefiting out of the AI? It is definitely showing that we are moving fast. I think the first speaker was talking about how many POC level projects are happening, but a very few of them are actually going to production. And that's true. That's very true. And it's happening everywhere. So measuring what actually adds value and then giving that feedback loop to fix the problems is very important. For us, one of the metrics that we said is instead of just seeing lines of code generated or accepted, track how many lines are actually going to production. You don't want a funnel structure. We actually want a pipeline. That's an ideal world. And time to value tracking. Velocity is another aspect. If your team spent, let's say, um, sprint delivering 20 points, now are they delivering 40 points after AI? That's a very good indicator, right? How many of you follow sprint models and pointing? Pretty much everybody. Yeah, so before AI, after AI, track it. That's one way of showing metrics. Then quality metrics, bug rates. So did it reduce the bugs or did it increase it? I actually wanted to hear from the developers. What do you see in your companies? Did it actually increase or decrease the bugs? There are a few cases where developers, they're generating a lot of code. They just push it without understanding what exactly is written. And I hear that they're struggling when the defects come because they are not the ones who wrote the code. So is that a true story or is a myth? I see a node.
From what I've seen, it's about the same.
It's about the same.
The same developers that are a little more sloppy are still sloppy. The ones that were always
Okay.
were,
Okay. Okay. At least that's not a good news or a bad news. Okay. Yeah, I know you can't read all the code AI is generating, but I would suggest at least you understand the critical components of it before it goes to production. And then unit economics by model. As I said, models are extremely important. Which one you use, what purpose. So use your judgment there. And it is a constant evolution. Um, when I told Padma I'm not in a good state today to talk, she said it'll be in September. I said, okay, AI is going to change by then. So uh, anyway, so that is how it's moving fast. So that is why I said, okay, these strategies, whatever I'm talking about, is not going to be relevant on the September. So I'm going to be here and talking. So that's the feedback loop that you guys have to build. You always measure, analyze, optimize, deploy, and you're not bound. Review, do it over again, because this AI environment is constantly changing. And it is very important as a developer and as a leader to stay on top of the changes that are happening. I come here not just to give the learnings from my industry and my company. I also learn from other speakers, and sometimes you normalize certain experience. Oh, it's not just me; it's happening elsewhere. Those are some stuff to learn from, and I've learned a lot from this forum itself, how they manage costs and stuff. So yeah, so keep learning and keep doing, and just try to optimize and do that over and over until there's no until you just keep doing it. All right, thank you. I made it without much cough. Any questions? You can use it. I can use it.
Okay, I get it. Thank you very much for a great presentation, and also Alex for this presentation. I have a question probably relating to both of you. Those three-tier architecture you mentioned, deterministic, we have open source. I think, can you comment on sort of the security risk for using open source stuff? Because at startups, we use open source all the time. You probably all heard like or got hacked, and then turns out it was one of the open source component that was kind of the gateway for the attack. So thoughts?
That's a great question. But I'm not a security expert. So I'm going to say what I do as a leader to make sure that it's a secure. We fill in a form with a security review and make sure that security team approves. If they approve, we just push it. So maybe I'll forward the question to the security person.
So your question is more specifically about open source stuff. These are open source models. So we are starting to use more open source models ourselves in our product, partly because we've got a SaaS and self-managed deployment version of our product, but we have a couple of customers and an increasing number that want to deploy the physical hardware on-prem, including air-gapped environments, which is forcing us into open source models. I have some observations too, which they actually work pretty well. We can get them to work pretty well on supply chain. We only use like one source in the US. That's not a foolproof thing, but like some of our customers are in national security, including intelligence community. Like we cannot even introduce that supply chain risk on our side. So I think it's a concern. I would definitely be very cognizant of what source model you pick and where it came from. Yeah, like the only ones we're looking at are Gemma 4 and GPOSS. So do what you want with that, but yeah, those are the only ones we're evaluating currently. But yeah, it's worth keeping an eye on.
All right, questions for me, please.
Your relay architecture, could you talk a little bit about how that works? Is it a multi-step process? Is it a customized solution based off of any? How did that actually work?
So we used LangGraph. So LangGraph is a very good language to write agents for. LangChain and there are Crew AI, but we loved LangGraph much better. So what we did is we broke down. I'm just going to walk through the steps. Okay. So we broke down the number of steps that we do for actual document generation. As I said, see if this file exists, read that file, see if this person is authorized to read this document. So all of these, right? So out of that, we made a checklist and we classified that as, okay, this is a deterministic step. If this person has access, read the file. If not, tell him a message that he doesn't have access. This is very deterministic. So we wrote all of that in a programmatic way within LangGraph. There was no LLM involved. Now we are reading the file and generating the documentation. That's where Gen AI comes, right? So we use open source model for that. But for eval, just to understand the quality, if this meets the expectations, we have certain parameters, and that's when Claude comes in to play the eval role. It understands what's the quality of the document, and then reinstructs to the open source model to fix and then rerun the documentation. That's how we did. Did I answer your question? Okay, thank you. How many of you were able to relate to the stories I said about the coding agent, coding fast AI coding tool? You were able to, with the cost, and you were able to. How about the agents? Agents, you guys are still using LLMs and giving a high level prompt? Okay. Mhm. Okay. For AI coding tool, like for generating the document.
Yeah, for generating the document as well, but in the sense of product requirement documents and the pay and the reason.
Okay.
I have a special tool, you know, and it keeps track of all the documents and how places and
I see. Okay. Okay, good to know. All right. Any more questions?
Hi, since topic of open source, I have a question on that. Now you can see that using self-hosting the whole electric tokens. Have your own gap system where you can run rendering on the sets. Personally, I had a lot of success for both the regeneration and code generation with self-hosted models, but you need to be really understand what
Exactly. You're right. That was something we considered and still considering. Right now, we are picking the open source models through Fireworks. But if you have to host, as you said, there is an infra component involved, there is a separate cost involved, sometimes even the training that we have to do for these open source models. So we are still evaluating, but for now, we are going to stick to the frontier models. And then when we scale up and go over there. We are not there yet. This is just an experiment, like with just one agent. So when we want to self-host, we are planning to do multiple experiments, like work with the engineers, work with them to use open source models and see the success criteria is met or not. Then define, if we have to self-host it or not. So it's a long way to go, but that's one of the options that we're still considering. I mean, maybe that could be a good investment if this works, right? Yeah, it'll scale really well in a long term, but we're not there yet. Thanks for the question.
Okay, I'd like to invite Alex and Lana so that you can all ask your questions too.
around the line of code traffic. Can you say the like uh, but however, one of the key relay integrity areas like more fast and faster. But just trying to be high and like fun. I am not releasing the better and faster. There is a database.
That's a very good question. I was expecting that. there is something about going with speed in a steady way and or going with speed recklessly. So what we consider this, where you're generating thousands and thousands of lines of code, but your actual value that you're adding to the production is very few lines of code, that is not speed for us. The speed is you are generating and pushing as much code as possible that's adding value to the business. Speed is not just you generate the code and then trash it. So that's why these measurements are very important. I don't think it is slowing us down. Maybe not as fast as you just keep pushing. It is slowing us down in a way that we are going to work very effectively. So that's how we think about it.
Just a second. Uh, Before the next question, actually, I want you, everyone here, just to scan the QR code, and it's the event that we posted on LinkedIn. We just want your feedback over there, how you like it, what any points that you have learned today, and or else you can just comment it as I'm here today. That will just boost the post, and we could reach more number of people. Thank you so much.
Thank you, Fanny. Any more questions?
Answering the last question you mentioned about measuring the value.
Right.
So how do you measure the value? I mean, you
It's a very good question again. The industry is still figuring it out. Okay, there's no good answer yet. We're just trying to pick some of the measurements. One of them I said was the number of points that you'd get delivered before and after AI as one of the ROI measurement. But there's no clear ROI measurement yet in the industry. We are still figuring it out.
fresh.
Do you use any AI in testing the code?
Well, that's something we want to explore. We haven't started yet. We still use automated tests like JET and Playwright, but we haven't started to use AI. But that's the next we have in pipeline. Because there are a few cases where we can use agents. For example, I don't have to execute entire suite of tests if I know only a certain lines of code are modified. So AI agent can intelligently select those test cases that are associated with the lines of code. So in that case, you run fewer tests that where it matters to run. So you don't have to run entire suite of tests. It cuts down your lead time to code reflection. So that's one of the use cases we're thinking about.
One thing related to using the open source code, the, the main intention is reducing cost or reliability with the other one. So, and in what scenario, what are the use cases you use those open source? There might be some competing models. What are your criteria in selecting those?
I'm going to be honest here, it was pretty much cost. So if Opus model and DeepSeek came at the same price, I would definitely use Opus. Yeah, it was purely cost, at least for me. Do you have any other use cases for using open source models?
I can add to it. It's kind of related. Definitely cost. That's the main driver. So even so just the say to some of our internal operations, like I said, we use elements as part of like that is the foundation of a lot of things that happen inside the product itself. What what I found like about a week or two ago was that our own testing of our own product, like in our dev staff, combined with we had a demo staff, demo deployments, we do a lot of in-house sales, so we like our demo deployment was so far above the cost that our kind of customers are paying for right now, and we're still early stage, right? So we don't have that in a mass customer base. So we started like Sonic 4.x is our main model we use in the product. So we started having everybody in the team who's testing use the open source models when they're testing. Because, for example, a UI dev in the team that's trying to do some integration testing in our product, they don't need the fidelity of like what competition, right? They can use, yeah, even if the output's like not that good, it's still good enough for testing the front end of the product, right? It doesn't really matter how good the answers coming back from the agent are. So yeah, so cost is a really big one for us, especially when we're talking about like our devs testing our own product. We don't use the main model that we give to all of our customers. But the other one is this air gap deployment thing on physical hardware is actually a big deal. Like we actually have scenarios that are not cloud connected, so we have got to be able to run on hardware. So I think for companies that have a lot of we talk a lot about the cloud, but there are some companies and a lot of them actually deal in like things that maybe don't have network connectivity. So I think there's a lot of use cases for open source models there. Or maybe they don't want network latency because the network's not reliable. That's another case. So yeah, I think we'll see more of that as AI gets adopted more into those use cases. But it's still kind of nascent for that right now. Everyone jumped on the cloud bandwagon. So
Right. We see sort of people who use open source models when they have like need to kind of fine tune or kind of tweak it on top of kind of the general purpose models.
Hi. One of the projects that I manage is to strengthen the external data connection from investment management system to other financial companies. So we would strengthen the firewall using F5. But on the other hand, I hear that the bad guys are developing quantum computers to hack everything in 5 years. So, how positive do you feel the battle is winning from our side?
this is the post one, right? So I'm going to fully admit I have not studied the whole post one world yet. I mean, I know that at a high level. Like at a high level, we definitely are on a great technology that will crack all the encryption algorithms very quickly that we have. So we're going to need something substantially different. In what time frame do we actually expect it's going to happen at scale? I'm not sure, right? A lot of times, so one thing I'll say on security side of things is that it's one thing to do something one time. So like what we see with nation state actors is they will spend a very, 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 very large amount of money to go after one target, right? But that's not financially working. That's like, well, we're gonna go hack, like whatever, like US or some countries like I don't know, water treatment facilities, things like that. It's a very motivated actual doing that for some reason. But the person started to get out there, the larger scale attacks at banks and things like that, a lot of times those are actually like criminal organizations run by business people that are trying to trying to figure out what's a good way to extract money cheaply out of this organization, right? Most ransomware is like that. And so those are the things that sort of happen large at scale. Now, so why do I bring that up? At what point is it going to be financially worth it for people to be running a bunch of computers that are not going to be cheap to start cracking everybody's breaking into like their secure protocols and everything like that? And what return are they going to get on that? I don't know. The cost equation might not be worth it in some ways. Those, if you've read the articles on like Mythos, the vulnerability found in OpenBSD took they estimated $5,000 cost just to find that one vulnerability, right? So some of the interesting articles I read were ones about the financial incentive to like do that scale. Like who is going to pay hundreds and thousands and millions of dollars to find all these vulnerabilities at scale? Once you find them, then you've got to figure out how to exploit them. Still more money, right? So I think this is what remains to be seen. The technology will probably eventually come. I don't know when the financial incentives will be such that like everyone starts getting hit by these attacks. So that's what we got to figure out. But like everything in security, it's a cat and mouse game. And so what will happen is the second the financial incentives are there, the technology's there, the defense is going to come right after it, and you're going to have new vendors selling new products to move you from to the post-quantum world, right? So doesn't quite answer your question, but that's kind of how I see it evolving.
Thinking about my future.
Yeah, yeah. I mean, I don't know, like these technology revolutions, even like AI, they're big like step functions in how well you can do something or the scale at which you can do it. Um, and so yeah, I'm thinking about it now. I know I can tell you that kind of U.S. government level, they are actively tracking it, watching where things tracking. So I wouldn't say like we're in a spot where like we're in trouble now. I think we are. I think it's coming, but it's not quite here yet. And just another little anecdote on this. People get worried about really sophisticated attacks. Everyone gets nervous about, oh my gosh, we're going to AI that goes and runs rampant in my system. We talked to a very large financial institution in the United States, one of my friends, based in the United States. And we asked them, what is your top problem? They're like, I can't put in bold letters on our text like verification thing. Share this code with anybody. And the number one problem they have, people still, someone will call them because they give them those 2FA type attacks, and they give them the code of the phone. That is still their top problem. So, like, we're talking about opening the door to shut and like, oh my gosh, I have security cameras, whatever. And all of the most common attacks are people are just like going from door to door, like, is this phone unlocked? Is this phone? Oh, that front door is unlocked. They're locked again. So we're still in this age where like the easiest the path of least resistance is not the oh, I'm gonna crack your like your SSL protocol or whatever. It's not that. It's just people just falling for dumb tricks. It's still the biggest problem. Or people getting fished for credentials. That's really big. Because phishing attacks have gotten very sophisticated. So that gives you kind of a picture of what's kind of going on. So yeah, we should be worried, but we just have to.
One follow-up question. Let's suppose you end up with a security incident while you guys are using the open source. So how do you contain that? That's something that
Yeah, and when you're asking, do you mean, so it could be a couple things. It's like, are you thinking about like using open source as the algorithm for coding and therefore you develop insecure code as a result?
not
Or
insecure.
more like you're using it in a product you're delivering.
Yes. So in a scenario where you're using open source models and then you found some vulnerability and then you immediately have to contain that.
Yeah. I wish I could tell you we've come up with a like, oh yeah, we totally know what to deal with.
Yeah.
Companies and supply chain and stuff in our open source or in the models. So one thing I will say about this is that like the way we built our product, we are not moving to any one model. We're say it with some pumps. Which kind of helps in case that like so for example, let's say you found let's say it was something that said, okay, I just found PTO that's a major issue with it. It's very easy for somebody to trigger this whole backdoor thing and boom, just close, right? We can figure it out. Well, that is normal. We're gonna flip every customer immediately over to some model. So we have kind of multiple of these that we use. The nice thing with Alpha is it's got a pretty standard, relatively standard protocol associated with it. The code and the structured output are a little different than each other. But for the most part, it's text in, text out. That is different than saying my UI framework has a known vulnerability. I can't change UI framework, so I need to wait for the patch and then I need to patch it. That's a little harder to do with LMS, especially open source ones. So yeah, we've kind of remained model agnostic. I think that's something I've really recommended people doing is that like be defensive in this world where possible because you don't know at what point you're not going to be able to use some model. And the story I'll give you on that. As I mentioned, we do work with national security. So when the whole thing happened in the Department of War, where they said we are no longer working with Anthropic, that affected us bad. I was on the runway on a plane and I got a call telling me I needed to my team needed to shut down one of our customers' endpoints immediately. So I'm trying to coordinate whatever, and it's because we were using Clawsonic in their endpoint, and it was US 2000. And their immunity and their immunity terminated everything with so we had to turn our plan off completely. And we did have an alternate plan. It took us time to implement, but I just kind of showed you how like this whole LM thing, this is part of the supply chain, and there are risks associated with each of these. I didn't expect that particular risk that the U.S. government would decide that a particular model is no longer acceptable, but yeah. So yeah, I think being defensive on the models and having a good strategy to swap one in and swap one out, I would probably recommend that to everybody.
Okay, thank you so much, Alex. Yeah, you can all, if you have more questions, you can all connect individually with all the speakers and carry on your conversations outside the room. But before we leave for one last time tonight, can we all take a group picture so that we capture this May 13th event and we know who all of your faces have attended to this day? If you all can like just walk up to the front and we can take a picture.